Welcome back to the second video in this series where we are implementing the Eller's maze algorithm, an infinite procedural maze algorithm within Unity. In this episode, we're going to be covering the project setup, coding our grid, and are going to be coding steps 1, 2, 3 of the algorithm in Unity. This video is fairly code heavy, and while I'm going to walk you step by step through the coding process, I recommend you have a decent understanding of C# and programming within Unity. I hope you find this video useful or interesting. Now let's get straight into the project. So first thing we're going to do is create the project, and it can be any version you want, but I'd suggest 2020 or 2021. I'm going to be using 2021, and it's going to be 3D, so you can do HDRP, URP, or just standard. Personally, I'm going to do URP just because I like the shaders, but you can name it whatever you want. And then we'll get into the project setup. So now we have a new project. The first thing we're going to do before we create the maze algorithm is create the grid. So I'm going to create a new file. I'm going to call it custom grid, and I'm going to open it up. So my grid implementation is going to be heavily inspired off another YouTuber called CodeMonkey. He has a video on grids, but I'm using his version because it's pretty bare bones, lightweight, but it gets the job done. So let's start coding this. So we're going to create a couple of variables. Create the width, the height, cell size, and the origin position. So the width is how long the maze is, the height is how high, the cell size is how large our cells are going to be, and the origin position is where our grid is going to spawn. Now the grid array is the most important variable. It's actually going to hold and organize our grid variables. Specifically, this is a 2D array. So the first value is going to be the x, the second is going to be the z. It's going to hold every x and z value, however long and high our grid is going to be. So now we're going to create a constructor. And a constructor is basically a function that runs when you create an instance of the class. And specifically, the variables that you pass into the constructor are going to set to these variables. So I'll show you what I mean. So essentially what I've done is I've duplicated the variables above and passed them into a parameter. So what we're going to do now is we're going to set these values equal to whatever we pass in. And now for the grid array, we're not going to pass in anything to the constructor. Instead, we're going to create a new instance of it. And we're going to pass in the width and the height. So let's say we had a 10 long width and a 20 long height. We're going to have 10 as our max x value and 20 as our max z value in our grid array. So now this is technically all the functionality we need for the grid to get working, but it's not going to be super useful when used in conjunction with the maze script, and we're also not going to be able to see it. So the first thing I'm going to do is I'm going to create a couple helper functions, and then we're going to do some debug to see where the actual maze is. So the first thing I'm doing is creating a getter function, which is just going to return the cell size. So the next function we're creating is another getter function. We want to get the world position when we input grid coordinates. So what we're doing here is returning the vector3 translation from coordinates on the grid. And we are setting the y value to 0. If you wanted to have some customizability and be able to modify this value, you'd have to do some editing yourself up here. But I think 0 is just going to be the default. And we're multiplying by the cell size and adding the origin position. That just takes into account the cell size and origin position. So now we're going to create one more helper function, and it's actually the opposite of this. Instead of getting the world position, we're going to get the xz coordinates when we input a vector 3. So basically what's happening here is the opposite of this. We are getting the world position, subtracting the origin position on the x, and divided by the cell size. We do this for the z as well, and then we get the grid x and z. And we're returning in an integer array with the x coming first and the z coming after. This will only ever be 2 items long. So now the last thing we have to do for the custom grid is create a debug so we can actually see it. So what I'm doing here is I'm looping through every x and z value in our grid array. This gets the x value and this gets the z value. And what we're going to do is we're going to draw a line from the current x value to the next x value and the current z value to the next z value. So basically what that's going to do is draw a line between every cell. How we're going to do this is we're going to do a debug that draw a line. And we have to have a start position, an end position, a color, and how long we want the line to show. So for the start position, we are simply going to get the world position of the x, the current x, and the current z value. For the end position, as I described, we are going to do the next x value. And then we can do whatever color we want. And let's say 1,000 seconds. Now we have to do this for the z value, and it should be working. So now we have a working grid, and all we need now is a grid spawner. So let's create a new script. Call it whatever you like. I'm going to call it grid spawner. Open it up. Now for the grid spawner, not too much to it. We're going to create a couple of the same variables. So I'm going to go over to my grid class, copy these 4, and turn these to public. Now I'm actually going to change this to a game object, and you'll see essentially what I'm going to do is just take this game object's position, and that's where we're going to spawn the maze. The final thing that we want is a reference to the grid that we're going to create. So when we create the maze generation algorithm, that script can access it from the script. Now all we have to do is actually create the grid. And this is how our constructor works. Now all we have to do is pass these values into this instance. Now if we go back into our game, we can create 2 objects. One is going to be our grid spawner, and one is going to be our grid spawn position. I'm going to set this to 0, 0. This can be wherever you want it to be. We're going to add the custom grid. Excuse me, we're going to add the grid spawner. I'm going to make this maze, or this grid 10 by 10, and have a cell size of 10. And we drag this here. Make sure this is checked on, otherwise you won't be able to see the debug. So actually, super quick edit, we need to change this to hide an inspector, not serialized reference. Now we can drag the grid position here, and we should be able to see our grid. Great, there we go. 10 rows high, 10 rows long, 100 cells total. Now we can actually start coding the algorithm. So now we've completed the grid, we can finally move on to actually creating the maze. So I'm going to create a new script. I'm going to call it Eller's maze generator. I'm going to open it up. Alright, now we can delete the updated start function. The first thing we want to do is get a reference to our grid. So let's get a serialized field and get a reference to the grid spawner. And now we can get a private reference to the actual grid. Alright, and in our void start method, we can set this equal to, or we can set this equal to grid spawner dot grid. So now let's jump into the maze generation. So I'm going to create a method. And if you remember from the first episode of this series, I went in pretty deep depth on the 5 steps of the Eller's maze generation process. But if you don't remember, basically the first step is that we create an empty row of cells. The second step is that we will assign any row that has empty cells a unique set value. In the third step, we either place walls or join cell set values. Fourth is placing at the bottom walls. And then the fifth is deciding to continue or to end the maze. So I've pasted here essentially the short form of all these steps. Just so when we code it, it's going to be a lot easier to divide the steps and work on them individually. So the first thing we're going to do is step 1. So we can ignore all these. So step 1 is to create a row of empty cells, which is the first row. Okay, so what I've created here is a list of tuples which are made of integer arrays and an integer. So basically this is going to be our list of cells. The integer array is going to keep track of a cell's coordinates, so its x and z value on the maze. And the integer is going to keep track of the cell's set value. So let's say we have 10 cells, there's going to be 10 values in this list. And each one of these is going to have, again, a coordinate and an integer. However, this is an empty row, so we need to assign each value a coordinate and a set value. So I'm going to create a for loop. So I've created a for loop. We're looping through the x. I changed this from I to x because we want to go through each value of the row width, so how wide our row is essentially. So our max value is going to be our grid spawner width, which is the grid width. And now we need to assign tuples to each of these values. So let's create the first value of the tuple, which is the coordinates. We have chords now, and the first value is going to be the x because as we keep iterating through this loop, it's going to increase. So we're going to get every x value on the first row, the 0th row of the maze. So now we need the set value. And I know the first step is to assign a row of empty cells. We're going to ignore this somewhat, and we're just going to combine it with step 2, just to save time. So we don't actually have a set value to assign. So we're going to create a new variable, a new integer. I'm going to call this max set value. We're going to set this equal to 1. And what this is going to do is every time we iterate, every time we create a new row, or every time we assign an empty cell with a new unique cell value, we're going to add 1 to this. Meaning every time a cell is assigned a new set value, it's going to be a brand new unique set value, which has never been used before. So this is only going to be used in this set, in this part, and in step 2. So for in this instance, we're going to have the coordinates, and this is going to be values 1 through 10. All right, so now we have the coordinates and the tuple. Let's add this to the list of our first row. And now we have our first row. The problem is we can't see it and we don't know if it's accurate. So I'm going to create a helper function. So we're going to have a new region, name it helper functions. And this first method that we're going to make is going to be called private world text row. Alright, so essentially what this function is going to do is we're going to input a row through the parameter, and for every cell value in that row, we're going to place a 3D world text object where that cell is and what the cell value is, or what the cell set value is. And this is going to be the parent of every child text object in the row. So we're going to loop through every cell tuple in the row. We're going to get the coordinates and the set value of each tuple. And then we're going to create the game object world text. And then for the text object, we're going to assign the text value to be the set value. And we're going to change the color as well. Now we need to place the text object in the accurate position to where the cell is. In this case, I'm going to place it in the center of the cell, just so it's the most visible and easy to see. So what I'm doing right here is I'm calculating the vector 3 position from the coordinates of the cell. This is a little bit complicated, but essentially what I'm doing is I'm getting the position to where the object is in the center of the cell. And the y value, this is the parameter that we have in the function. I'm adding this because we're going to have multiple rows and they might be overlapping. So it's going to be useful to distinguish if we have two texts of row on top of each other. We're going to place one on top of each other so we can actually see the two cells. And finally, now I'm going to actually place the object, and I'm going to make it a child of this object so each row is easy to distinguish from another. Alright, so now this is finished. We can use this up here, and we're going to input our first row. I'm going to make it color.white. And I'm just going to do on the 0 y value. And before we go back to the inspector, make sure you call this in the start function. Now we can go back. I'm going to create a new game object. Call this Eller's maze. And I'm going to get the maze generator, drag our spawner. Then we should press play. And there you go. You can see each cell and its set value. So this is only the first row. We're not doing anything special, but this is exactly how it should look. So now we can move on to the main maze generation loop. If you remember from the video, it's steps 2 through 5. I'm going to delete this. This is more accurate in how it's going to look. Basically, we're going to input a row, join the vertical walls, add the bottom walls, and then if we decide to add a new row, we'll implement step 2, which is assigning each empty cell with a new cell, and then we'll go back to step 3. However, if we want to finish, we're actually going to check to see if it's the last iteration in the loop, and we will check the final row before doing the rest because we don't want to do any of these behaviors as the final row has its own unique behavior. So to start this loop, I'm going to create a for loop. So the first thing we're going to do, now that we have our first row created, we're going to take this first row and input it into step 3. to start this, we're going to create a new function. Alright, so I created the function called join row vertical walls. You can name it step 3, whatever you like. But essentially what we're going to do is we're going to take a row as the parameter. So we need a row to do stuff to, right? And then we're also going to return the edited row at the end. The first thing we're going to do is we're going to make a copy of this row actually. And this is how you copy. You just put the old row into the parentheses. Now we're going to create a for loop. We're going to loop through the row copy.count, which means we're going to loop through every value or the amount of times there are cells in this row. So in our case, if we have a 10 width, it should be 10 cells. Now we're going to make an if statement. So this if statement is very important, and essentially what it's saying is that if I plus 1 is greater than row copy.count, then don't enter the if statement essentially. So as long as I plus 1 is less than the row copy.count. And this is because we're going to be comparing the current index and the next index, so I plus 1. And if we don't do this check, we're going to have index errors. So now we're going to create a couple variables. Okay, so we have a reference to the current cell we're iterating over and the next cell in the set. We also have a Boolean join value, and this is going to be important for when we actually decide whether to join or place a wall. Right now it's set to false, but we're going to add some functionality to decide the randomness of whether to join or not. So the next thing we're going to do is the first prerequisite that was mentioned in the video, which is essentially saying that if the current cell value and the next cell value are the same, you will always place a wall in between them. So essentially, if this happens, we just set join equal to false because we're placing a wall. Otherwise, we can decide to randomize to join or to place the wall. Alright, so what I'm doing here is I'm generating a random integer between 0 and 100. I know it says 101, but random.range is exclusive, so the top numbers are actually not going to be included. You got to add 1 for whatever number you want. So what I'm going to do with this number is we're going to use this with a custom function that we're going to make, which will allow us to return a certain percentage of something happening, if that makes sense. So specifically in this case, we're going to have a percentage that we want the wall to spawn. So let's say we have a 70% chance for the vertical wall to spawn. We're going to create a function that allows us to do that, essentially. So let's go down here. We're going to create a new function. So essentially, the parameters, we're going to put in a number, and we're simply just going to check if it's within the min and max range, and it's inclusive, meaning if it's less or equal to or greater equal to. So if we have a number, this number is going to be our random number. Our minimum range is going to be 0, and our maximum range is going to be what percentage we want it to set to. So if we have, let's say 70, there's going to be a 70% chance for this random number to be between 0 and 100. And if it's not, then it's going to return false. So let's go back up. So we're going to create the function. Alright, so what we're going to do is actually create a new variable. It's going to be an integer. It's going to be right wall spawn percentage. We're going to set that to 0. And we're going to do one more thing. We're going to create a range 0 to 100. And this line is actually going to create a slider that we can slide in order to choose a number between 0 and 100 in the editor. And again, what this is going to do is it's going to set a spawn percentage for our right walls. So if we set this number to 70, there's going to be a 70% chance that during step 3, when it decides to choose a wall or join the cells, again, a 70% chance to place a wall. So we're going to put it in here, and that's going to act as the spawn percentage. And if it is in the range, then we're going to set join is equal to false, because we don't want to join the cells, we want to build a wall instead. If it's not within the range, then we are going to join the cells. So now we've gotten the random percentage for joining and placing the wall. Now let's actually place the wall and join the cells. So for the wall, we have not actually created any functionality. We're going to do that in a second. But we're going to need to create a function which will place the wall. So if we do join, what we're going to do is create a new cell tuple. Now, if you remember back for step 3, if we do decide to join the cells, what we want to do is for the adjacent cell to take the cell set of the current cell we're looping over. So we're going to keep the next cell's coordinates, but we're going to adopt the current cell's set. And now all we have to do is replace the next cell's tuple as this new cell tuple. Alright, so now we can double check to see if this joining will actually work. We actually have to return the new row first, the row copy. But we can go back into Unity. Actually, in order to see whether the joining functionality works, we're going to have to put it up here and put our row. We're going to use the first row. We're going to get a reference to this. And we are going to create a world text just to see if our functionality actually worked. And for this case, make sure you just set this to 1. We will change it back when we actually create the maze. Otherwise, we're going to get 10 rows on top of each other. So if we go back to our maze, and we can set this to whatever we want, I'm going to just do 50. Obviously, we're not going to see the effects of this really, because we're not going to see the wall placement. But inversely, we are going to see a 50% chance of the cells joining. So let's see if we can see that behavior. All right, and there we go. We can see that 4 and 5 joined, 6, 7, 8 joined, and then 9 and 10 joined as well. So that's about a 50-50 chance. Now let's actually create the walls so we can actually see the wall placement and if it's working or not. So we're going to be inputting a direction and a cell coordinate, an XZ cell coordinate. The direction is just what direction our wall is going to be facing, because we do need vertical and horizontal walls in this maze. This is just so we are able to use it for both. So I'm creating a new variable here. I'm going to go up to the top. And we're going to call it and we're just going to create this to give you the option if you want to place your wall on a Y value other than 0. So let's just put that down here. Alright, so we are going to need a reference to a game object. We're going to create a prefab right after this. The position, this is just again the position that we created. And then game object instantiation requires a quaternion. However, we can use quaternion.lookRotation and just input our direction and it works perfectly fine. So let's create this game object. create a reference really quick. Let's go back to the project. I'm going to create an empty object, and I'm going to create a cube. So our cube is going to have to be however long our cell size is. So unfortunately, there's no other way to get around this. So if you change the grid size to like 20, you're going to also have to change the prefab. That's just how it works. So in our case, our cell size is 10 long. So we're going to make our wall 10 long. And then the height can be whatever you want it to be. I think 5 is pretty good. So this looks good. However, the problem is the pivot is in the center of the object. So if we place the position wherever the grid axes are, it's going to actually place it in the center of this object, and it's not going to look good. Now we could code something to make it center appropriately, but we'd have to do it on both axes. And honestly, it's just a lot easier to create a pivot, another game object. And we're going to drag our cube. Make sure these are both set to 0, 0. And so this is our new pivot. And what we're going to do is put this up. It's going to be half of the cell size. So now you can see our pivot is actually at the base of this wall. So when we place this pivot at the grid axes, it's going to be here. And it's going to look like a chip. So now we can drag this, make it a prefab, and we can drag it into our reference. And now this function should be working fine. And let's go use it in our vertical walls. So we're going to place a wall. Because it's a vertical wall, it's going to be vector3.forward. And we're going to be placing the wall at the next cell's coordinates, because the coordinates is actually in between the first and second cell. You're going to see it. It'll look aligned, but let's get the coordinate of the next cell. And then we can input the x value, which is the first index, and the second index is the z value. So now let's go back to our game. I'm going to move this out of the way. And there you go. Every time the cell set changes, there is a wall in between the cells, and that's exactly the behavior that we want. The only problem is that you can see we don't have one on the edge or this edge, and we don't have any on the bottom. So we're quickly going to modify that. So for the far left, we want to create a wall before any of the looping occurs. We're going to want to create a wall at the row's first cell. And again, essentially what I'm doing here is I'm getting the first cell in the row, and then I'm getting its x value and its z value. So we also need one for the last wall of the maze. We'll do it right at the end. Okay, and for the final row, what we're gonna need to do is, instead of getting the first item, we're gonna get the last item. So row copy.count -1, and then row copy.count -1. However, for the x value, we're going to add 1, and that's the only change that we do. And there we go. You can see that the far left edge and the far right edge both have walls. And if you want to double check, there's no duplicates or anything. So the vertical walls are working, and they should work every time we iterate. So that's actually going to be all for this video. There should be at least 2 more episodes in the series before we finish, with the next video coming out in no more than 2 days, I promise. If you guys enjoyed or found this video useful, let me know in the comments, and I'll see you guys next time.